So hey everyone, in the last video we had understood the bubble sort algorithm and we found out that it was not even efficient. So now we are going to explore more sorting algorithms. So in this video we are going to specifically focus on the insertion sort. Okay, so I'll just tell you what exactly does this sorting algorithm actually work. So basically insertion sort is a simple and intuitive sorting algorithm that works by gradually building a sorted portion of an array. Okay, so this actually works by the divide and conquer rule. So where we divide one particular part of the array which is sorted and other part of the array which is unsorted, and I'm just going to explain how exactly it works. So first thing is we just need to start from the second element. So we need to assume that the first element, that is 7 over here, which is already sorted over here. Okay, so then we just need to assume like one part of this, so that is the left side of this is sorted, and then all the other elements to the right are unsorted. Okay, so as we keep iterating across every number, so all the left portion will be sorted and all the right portion will be unsorted, unless we reach at the end of the array where all the elements will be finally sorted and all the there are no more numbers on the right side that are actually unsorted. Okay, so this is the first step. We need to get started from the second element. Then we need to compare the current element with the elements in the sorted portion that is on the left side. Okay, so we compare 7 and 3. So you see that the 3 should come before 7, right, to be sorted. So what we do is we shift 3 to the left of 7. Okay, and then again we bring them to the center like this, and now we see that this is the point where the left side of the array is sorted. Okay, so now we need to consider the elements from the right. Now we go to the second index, that is at number 9. So now we check the number 9, which place or what is the index that it has to go to make the left side of the portion to be sorted. Okay, so we don't need to make the shift because 3, 7 and 9 are already sorted. Okay, so then we go on to the next number. So I hope you get the idea how do we need to do. So you see 2 over here, so we need to sort this, right? So we need to place this 2 in which particular slot. So basically we need to insert at the first or the 0th index. So now you see that through 2, 3, 7, 9 are sorted and the rest of the elements are unsorted. Okay, so let me just bring this to the center. So now we are here where the left portion are already sorted and we just need to sort the right one as well. So now we go to the element 5 and we need to insert this at the index on the left side where it has to be sorted. Okay, so you see that we need to place it at the index, that is 0, 1, 2 over here to make this sorted. So 2, 3, 5, 7, 9, which is sorted, and last one finally the number 1. So where it has to go, so we need to find the index, right? So that is at index 0 over here. So you see that now all of our elements are sorted. So why does this name come as insertion sort? So basically we are inserting the current element to its correct position, right? So basically these are all jumbled up, so we need to place them to the correct index. So by basically comparing different elements, the value of them, okay, and then we place them to the right index. So after we come to the last element, we finally check that all the elements are currently sorted. So what is the time complexity involved in the insertion sort operation? So there are two cases. So the best case is if all the elements are sorted, so we don't have to find the right index for that particular element to be placed since it's already sorted, since all the numbers are already sorted. So we achieve that the best case as the time complexity of O of n. Okay, so this is the best case. And the worst case is that if all the elements are unsorted, so basically if we are having all the numbers in the reverse order, so that time it will be very worst. Okay, so that time we'll have a time complexity of O of n square because we need to insert every single element to its right index. Okay, so this is also the algorithm which is not actually efficient, but at least it's better than bubble sort. Okay, so that we need to understand. So the worst case is going to be of time complexity of O of n square. Okay, so this is how the insertion sort algorithm works. Okay, so let us see how can we code this. So inside JavaScript, so this is the function called insertion sort and it takes in an array. So we are just passing in the array of elements just as we saw in the example. So that is 7, 3, 9, 2, 5, 1, and inside this we are just going to get started by starting a for loop. Okay, which will point at the first index. Okay, since the first element is already sorted, so we can get started by let I equals 1 this time, and then I less than array dot length and incrementing I. So once we do this, we just want to grab the current element at the ith index. Okay, so let's store that in a variable called current element and put that equal to array at ith index. So now we just want to get the previous value. Okay, so the previous index. So if we are starting at IE, so we want to get what is previous of that, so that we can compare these two elements. So I can just set this to a pointer called j and set this to the index 1 less than I, so I minus 1. And then we just want to run a while loop while we keep doing the comparison elements and keep on shifting unless the condition is met. So basically we are just checking if the jth element is greater than the current element, okay, and also if j is in range. So let's put a while, and first we check j is in range. So basically if it is greater than or equal to 0, and then we just want to check the value of j, so array at j, and then if that is greater than the current element, so current element, then we just update the value of j plus 1 to the value of j. So suppose if the value of j is, let's say if I is over here and j is over here, now you see that j is greater than the current element, right? So we just need to make the value of j plus 1 over here to the value of j, so the indexes get shifted. So now we just say array at j plus 1 equals to array at j, like this, and now we just decrement j. And once we do that, so we keep doing this again and again until this condition fails, okay, so which means that is the right index for the element on the left side of the portion, just as I explained you in the example, and this keeps on going, and we just keep doing unless this for loops gets ended, okay. And after this while loop will be remained with the last element, right? So that is array at j plus 1. So we just need to update that to the current element, since that is the only element left and which is to be sorted as well. So that is array at j plus 1 and set that to the current element, okay. So finally we return the array, okay, so array which is already sorted, right? So return. So we just don't create any additional data structure, so we just modify the given array, okay. So once I run this file over here, so you now see that our array is sorted. So we pass in 739251, so we get back 123579, which is the sorted version of this, okay. So I hope the insertion sort algorithm is clear to you. So let me just repeat if you are not actually understood. So let's say I is at number 2 and j is at 9, right? Since so all the elements on the left side are actually sorted, so we just need to find the index where 2 has to go, right? So we just check within this while loop, and we check as long as the jth element is greater than the current element. So you see that 9 is greater than 2, so we update 9 and 2 like this. So we just make array at j plus 1 equal to array at j. So we just do this, and then we decrement j. So now j is at 7 and the current element is 2, right? So now we check if the array at j is greater than the current element. Yes, it is greater. So we just update the value of j plus 1, that is 2, to the value of j, right? So we just do this, and then now we decrement j. So now j is at 3 and the current element is 2. Again we keep doing that. Now we see that 3 is greater than 2, so we just update the values, so 2 and 3 like this, and then we see that j is now less than 0, right? So it is going before 2, that is at -1, right? So that is why we come out of this loop and then go to the next iteration. So that is at from 5. So 5 becomes now the current element, and the j value becomes 9, okay. So I hope you understood how this actually works, right? So we are finding the index where the current element has to be placed, okay. So this is all about the insertion sort. If you didn't understand this, or if you have any confusion, let me know in the comments, so I'll just try to help you out. So that's it, I guess, for this video. Thank you so much for watching. Make sure you subscribe, and I'll see you guys in the next video.